In parallelogram OABC, P is the point that divides OA in the ratio 1 to 2, and Q is the point that divides OC in the ratio 1 to 2. OP is P and OQ is Q. Draw a diagram to show the situation described. So, it's a parallelogram. If we call this O, always label around either clockwise or anti-clockwise. P is here, closer to O, remember divides in the ratio 1 to 2, and Q is here, and then this is the vector P and this is the vector Q. So find expressions in terms of P and Q for OA. Well, we know that's just going to be 3 lots of P, and OB, I think that really should say, well, it's OB, that's fine, OB, we can do that. That's going to be 3P plus 3Q. And then A to B, well, that's going to be parallel to OC, so that's just going to be 3Q. What about PQ? So that would be backwards along P and forwards along Q, so that is Q minus P. And AC would be backwards 3P and forwards 3Q, so that's going to be 3Q minus 3P. So those were straightforward enough. Now OB beats PQ at X. So what we've got PQ here, here's OB, and this point here is X. So OX is HOC. That should be OB. I'll go back and change that shortly. Find H. Yeah, it's got to be OB. So OX is equal to HOB, and we know that OB is 3P plus 3Q. So it's going to be 3HP plus 3HQ. Now let's think of another route to get to OX. So OX, how else could we get there? Well, we could go up here and then down there, like so. So that is going to be P, and we don't know how far along PQ. So we'd need to introduce another constant, K, and then we know that PQ is Q minus P. So that is going to be P plus KQ, take away KP, which is P into 1 minus K, plus KQ. Now, from here and here, we can see here that the number of P's is the same as the number of Q's. So that tells me straight away the number of P's here must be the same as the number of Q's. So K is equal to 1 minus K, giving me 2K equals 1, and therefore K is equal to 1/2.